Hello and welcome to part 3 of our semester 1 review. So we are picking up at number 30. So number 30 says, for the polynomial, find each of the following. And they gave me this polynomial that's already factored out, which is nice. Now we don't have to factor it. We just need to know what all the important parts are. So the first thing says identify the zeros. Remember, the zeros are what would make each of these linear factors a zero. So to make x equal 0, we would need a 0. To make x plus 2 equal 0, we'd need a negative 2. To make x minus 1 equal 0, we'd need a positive 1. And x squared minus 9, well, that can factor a little bit further. We could factor that into x plus 3, x minus 3, considering the fact that it's a difference of 2 squares. So plus or minus 3 would make that a 0. It also asks for the y-intercept, and this one's a little bit more challenging. For the y-intercept, we have to plug 0 in for x. Remember, the y-intercept is when x equals 0, what is the y value? Well, to do this, I'm going to need 0 here, and then I'm going to multiply all this stuff. Think about what's going to happen there. You're going to have 2. 2 squared is 4. 4 times negative 1 cubed, so that's going to be negative 1, so negative 4. Negative 4 times negative 9 is going to give me positive 54, but none of that matters because then you're going to multiply it by 0, which means we know the y-intercept is 0, 0. Next, we need the multiplicity of each 0, so I'm just going to respectively put them underneath each one. The multiplicity of 0, well, since it's x to the first power, the multiplicity of 0 is 1. The multiplicity of negative 2, well, x plus 2 is to the second power, so the multiplicity is 2 since it's to the second power. The positive 1, and this positive 1, again, this positive 1 is to the third power. So since it's to the third power, I know it's going to have a multiplicity of 3. And last, our x plus 3 and our x minus 3, both of those have a power of 1. So we know that these will each have a power of 1. The plus 3 and the minus 3 each have a multiplicity of 1. Well, part D says we'll explain what that means. Any of the factors that have a multiplicity of 1 or a degree of 1, what happens? Is it going to touch or cross the x-axis? So for 0, positive 3, and negative 3, they all have a multiplicity of 1. Well, since multiplicity of 1 is odd, it's going to cross the x-axis. What about the ones that have a factor of 2? So the multiplicity of 2 goes to the negative 2. What's going to happen at negative 2? Well, since that's an even multiplicity, it's going to touch the x-axis and then bounce off it and go around. And what about the factors with a multiplicity of 3? So that would be the positive 1 has a multiplicity of 3. Again, since 3 is odd, it's going to cross. Remember, any multiplicity that's odd, it crosses. Any multiplicity that's even, it touches. Number 31 says, list all the possible rational roots of the function f of x. So this one, we're going to do all the factors of the constant as the numerator and divide it by all the factors of the leading coefficient for the denominator. So all my factors of negative 12 are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and then 7, 8, 9, 10 don't work, 11 doesn't work, and so it's just 12. Divided by all the factors of the leading coefficient, which is 3. Well, the only factors of 3 are 1 and 3, so plus or minus 1, plus or minus 3. And then we want to make sure we go through and actually do our division there. So 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, 6 divided by 1, 12 divided by 1. So my first 6 factors are going to be exactly what's on the numerator. Plus or minus 6 and plus or minus 12. Then we want to divide our factors by 3. So 1 divided by 3, well, that's going to give me 1/3. So plus or minus 1/3. 2 divided by 3, so plus or minus 2/3. 3 divided by 3 is 1. We already have 1, so we don't have to redo that. 4 divided by 3 is 4/3. 6 divided by 3 is 2. I've already got that. And 12 divided by 3 is 4. I've already got that. So those would be all of our possible rational roots that could exist in this function. All right, going on to this back part here, number 32 says, which of the following are zeros for the function f of x given? So I could start by looking and seeing if I could factor this by grouping. That's going to be always my first thought when I have a cubic function with 4 terms. So grouping this together, on this top one, I can factor out 2x squared. So 2x squared out of 2x cubed just leaves me with an x. 2x squared here, well, the 2 makes the 6 into a 3, and then x squared leaves it as no x. Over here, it looks like I can factor out a negative 4. Negative 4x divided by negative 4 is going to be positive x, and negative 12 divided by negative 4 is positive 3. And since these are the same term, I do know this is going to factor into 2x squared minus 4, and then an x plus 3. Again, there is a greatest common factor. We could factor that too. So I have x squared minus 2, x plus 3. So I can come over here now and look for my factors. Immediately I know I need to find one that has negative 3 as a 0. So D is a possibility and B is a possibility, but A and C both have a positive 3, so it's not those. So it's either B or D. I can see that this one has imaginary, negative 2 and positive 2 imaginary I, and negative 2 and positive 2 square rooted. Well, let's think about this. This is kind of like a difference of 2 squares, except 2 is not square rootable. So the way I could factor this is I could say x plus or minus, and then take the square root of that. So the square root of 2, square root of 2, and then my x plus 3 at the end. So it's not going to give me an imaginary solution. It's going to give me the square roots. So it's going to be D. All right, going on to 33. 33 says, which of the following is a 0 of this function? So what we'd have to do is we have to go through and plug these in to see which one gives us 0, or use synthetic division. Either way will give us the answer. I'm going to go ahead and use synthetic division because I like synthetic division. So I'm going to put negative 2 up top. Cubed, squared, linear, constant. So it's got all my pieces, so I don't have to add in any zeros. 4, 9, negative 3, negative 10. And we're just going to go through and solve this for for synthetic division. We bring down our first number and then multiply. Negative 2 times 4 is negative 8. Add that together, I get 1. 1 times negative 2 is negative 2. Add that together, I get negative 5. Multiply that, I get positive 10. Oh, look at that. First try, because I got 0 there, that is a factor. So A is the answer. If you went through and tried the other ones, they all give you remainders. So I know that that's going to be my only answer that I have to be concerned with. 34 says, given that 1/3 is a 0 of the function, find the rest of the zeros. So again, what we're going to start by doing is we're going to start by doing synthetic division to figure out what we have after we divide out the 1/3. So I've got 3 cubed, squared, linear. Yes, they're all there. So 3, 2, negative 19, 6. So it's telling me this is a 0, so I should get 0 for the remainder. So bring down my 3. 3 times 1/3, or 3 divided by 3 is 1. Add that up, I get 3. 3 divided by 3 again is 1. Add that up, I get negative 18. Negative 18 divided by 3 is negative 6, and I get 0. So it does work, which means that 1/3 is a factor. Remember the way that we write 1/3 as a factor is we multiply the bottom number to x, and then add the numerator. Or sorry, this would be subtract the numerator. Hold on, that was not right. Subtract the numerator because it's positive. Subtract the numerator. So if we were to solve this, add 1, divide by 3, you'd get positive 1/3, so it does work. And the remaining part, since I started as a cubed, is now 3x squared plus 3x minus 18. Well, I can factor this pretty easily, actually. We're going to factor the 3 out. So I'm going to get 3, and then x squared plus x minus 6. And then I can factor that. Two numbers that multiply to make negative 6, but add up to make positive 1 is going to be positive 3 and negative 2. So that's going to be my factors. So if I bring this down all the way, we'll put the 3 out front, put my 3x minus 1, and then we're going to have our x plus 3, x minus 2. So all of my zeros are 1/3, negative 3, and positive 2. Those would be my zeros. This one says identify the end behavior. Remember, the way the end behavior is written is this first part will always say the same thing as x approaches negative infinity. That part says what's happening on the left side. And this second part after the semicolon should always say the same thing too, as x approaches positive infinity, what happens on the right side. So really these parts we can ignore. It gets kind of confusing when you look at all those infinities, but this part we can ignore. All we care about is this tells us, does the function go down, down, or up on the left side. And this tells us the function goes down, up, on the right side. So again, this is the right side, this is the left side. We're looking at the f of x part. So I'm going to first count by, well, first thing I notice is this is going to be positive, right? X times x times x times x is going to give us positive x to the fourth power. And then the other stuff is there. But I really don't care about the other stuff because these are the important pieces. The positive tells us what happens on the right-hand side. So right here, as x goes to infinity, the right-hand side should go to positive. So it can't be this one or this one because that says the right side goes down. So it's definitely B or D. The positive, or sorry, the even tells us that it's going to do the same as the right side. Even copies the positive sign. Odd does the opposite of the positive sign. So this is even. That means my left side should do the same. So B says that the left side goes down and the right side goes up. That's not what I want. D says the right side goes up, so the left side also goes up. So D would represent what we need our answer to be. Number 36. Which of the following functions could represent the graph? So I've got this graph. It looks like it's going up on the left and up on the right. So what we just talked about, we know then that it should be positive and it should be even. Positive for the right-hand side because it's going up, and then even because the left-hand side is copying the right-hand side. So what I immediately can see is that A wouldn't make any sense because A is odd, and we can eliminate that. And then B wouldn't make any sense because B has a negative in front, so it should be going down. So I know it's got to be C or D. Well, most of this looks almost the same. The only thing that's different is right here at the very end, this -5 and this -6. Well, let's think about what happens. If we plug 0 into this equation, at 0, I should get -5. Well, if I plug 0 into D, 0 plus 0 plus 0 plus 0 minus 6 is -6, not -5. But C, 0 plus 0 plus 0 plus 0 minus 5 is -5. So C has to be the answer because the -5 matches with my y-intercept. For 37, below is the complete graph of a polynomial function. Which of the following statements are true? So they've got this graph, and we can see it's kind of doing a few turns here. I know it's an odd function because the right side is going down, but the left side is going up. So I do know it's odd, which means A, it's a 6th degree function, can't be true. And D, it's a 4th degree function, also can't be true. So the only two things I have left is that x is a factor of g, and the multiplicity of x equals 0 is odd. Well, let's look at the multiplicity at 0. When x equals 0, it bounces off the x-axis. Did we say earlier that bouncing off was even or odd? Well, remember we said if it's odd, it would cross through the x-axis, and if it's even, it will touch the x-axis. This doesn't make any sense then. It's definitely an even multiplicity because it's touching the x-axis. So it can't be C, meaning it has to be B, which makes sense. X is a factor of g. Well, yeah, if you plug x in, it should be a factor of g, given that these x values are the zeros. So that would be your answer, is that x is a factor of g. 38 says solve the inequality given. So we need to solve this. The first thing I'm going to have to do then is isolate all of the values on the left-hand side together. So x cubed plus 3x squared minus 4x when I move it over and minus 12 when I move it over is greater than 0, which is left over. So I need to look at this and see if I can go ahead and factor it. And it does look like I can factor it by grouping as well. So x squared gets pulled out of these two, and I have x plus 3. Here I can pull out a -4, and I have x plus 3. So that means that x squared minus 4 multiplied by x plus 3 is greater than 0. Well, that can factor a little bit further as well because I've got a difference of 2 squares. That x squared minus 4 becomes x plus 2, x minus 2, and x plus 3 is greater than 0. So those are my critical points. If I were to draw a number line, I know that at -2, -3, and +2 are my critical points. So I need to figure out what's happening in between those points. So what we do is we take something like -4 and plug it into our problem. Plug -4 in and see what happens. So when I plug -4 in here, -4 to the 3rd power is going to give me -64. Negative 4 times negative 4 is negative 16. Or sorry, positive 16, and positive 16 times negative 4 is negative 64. Here I've got negative 4 times negative 4 is 16 times 3. So 16, 32, 48. So I've got negative 64 plus 48, which is going to give me negative 16. So I've got negative 16 on the, actually, let's just keep going through here. Negative 4 times negative 4 is going to give us another plus 16. So now I'm at 0. Minus 12 is going to be negative 12. Is negative 12 greater than 0? No, absolutely not. So this does not work. Anything less than negative 3 does not work. What this does is actually sets up a pattern. It should now go works, doesn't work, works. So let's just test this off. Picking a number between negative 2 and negative 3 is kind of hard. Let's pick something in between negative 2 and 2, like 0. If I plug 0 in, 0, 0, 0, negative 12. Is negative 12 greater than 0? No, still not going to happen. So this is not going to be a valid answer. And maybe pick something bigger than 2. We could do that. Pick 3. 3 times 3 times 3 is going to give us 9, 9, 8, 27. 3 squared is 9. 9 times 3 is 27, so that's 54. 3 times negative 4 is negative 12, so 54 minus 12 is 44. No, 42. And then 42 minus 12 is 30. Is 30 greater than 0? Absolutely. So far, most of it checks out. So let's just add our check in there because we know that's what's going to happen. It should alternate. And since this is a greater than sign, not a greater than or equal, we're going to use parentheses. So it looks like my solution is going to be negative 3 to negative 2. Union, we'll skip 2 to negative 2 to 2. We'll pick back up at 2 and go to infinity. All right, number 39 says, suppose that you have a not complete graph. So this graph is not completed. It could keep going. It has a local minimum at x equals 2. Ooh, so actually that helps me a little bit. I can finish this graph because at 2, or keep going, with 2 we reach a local minimum, which means the graph has to turn around, right? It's not the minimum. It's not the absolute minimum. It's a local minimum. So it's going to turn around and come back up and maybe go back down again. What has to be true about this function? So it could be a third degree polynomial, but with a positive leading coefficient. 1, 2, 3, 4. Definitely not. It's got to be even right now. So it's definitely not a third degree. It could be like a fifth degree, but third degree is too small. It could be third degree. Still can't be that. It could be a fourth degree polynomial with a positive leading coefficient. It could be because positive means it would go up on the right-hand side, and it goes 1, 2, 3, 4. It's got going up on the left and up on the right. So it could be fourth. And it could be fourth with the negative. It can't be that because negative would mean it was going down on the right-hand side. So it has to be C because it's even fourth degree. Both are going up. And it's positive because it's going up on the right-hand side. 40 says, based off the behavior you see in the scatter plot, what would be an appropriate polynomial to model this data? So you can see that they factored out some polynomials. There's also an answer D on the other page if you didn't see that. It looks like they factored some of this stuff out. So it looks like we need to acknowledge the zeros. There is definitely a 0, at positive 4, and at positive 7. So what that means is I've got x minus 4, and x minus 7 as my factors. But I also need to acknowledge the multiplicities because it definitely looks like at 0 it bounces and turns around back down. So x needs to have some sort of even exponent on it. And here it looks like it crosses at 4 and it comes down to 7, and we don't really know if it crosses or not. But what I do know is that x needs to have an even exponent. So this first one would be an easy answer because it looks just like ours, but that wouldn't work for x at being 0 because it doesn't cross. So A can't be the answer because it crosses the x-axis. I need an even exponent for this to work. So if we look at something like B could potentially work. It is an even exponent. And then I've got my other two parts. I do have a small issue with this, though, is that this is positive. But my graph is going down on the left and the right. So it should be even, but it should also be negative. So B is not going to work because of this positive. If this was a negative, that would be a good answer, which is a huge hint. Because if you take a look at answer D, that one's the exact same answer, but with a negative. I've got an even exponent, so it'll bounce off at 0. It's negative, so it goes down, and there's my other two zeros. So D should have been the answer we chose for that. 41, what is the equation of the horizontal asymptote for this function? Remember with asymptotes, we have to pay attention to what the powers are. So since the power on top is 1 and the power on the bottom is 2, we can determine our asymptote pretty easily. If the power on the bottom is bigger, the asymptote is always y equals 0. Remember what we said is if the power on the top is bigger, then there would be no asymptote. And if they were equal, we would divide the leading coefficients with each other. 42 says sketch a graph of this function without using a calculator. So the first thing I need to do is factor this. So I've got x and x plus 1. When I factor out the x on top. On the bottom, two numbers that multiply to -3 and add up to make -2 is going to be x minus 3, x plus 1. So it looks like the x plus 1s will cancel. So a few things I can get from this. One, since x is a factor on top, that is my x-intercept. There is going to be a point at 0, 0. My vertical asymptote comes from the denominator. Since it's x minus 3, I know there's a vertical asymptote at x equals 3. My horizontal asymptote, since these powers are equal, we're going to divide the leading coefficients. So 1 divided by 1, 1 divided by 1 is 1. So there's going to be a horizontal asymptote at 1. And last thing I need to acknowledge is there is a hole. When I cancel out my positive 1, that means there is a hole at -1. So at -1, if I plug -1 into this equation, I get -1 over -4, which is 1/4. So there's an open hole at -1, 1/4. So what I know then is my graph should look like that. And since there's no more x-intercepts, my other part of the graph can't be here. It would cross the x-axis again, so it's got to be up here where it can't cross the x-axis. That would be the other part of my rational function. 43 says, what of the following best describes this function here? And they gave me lots of pieces here. So I think the first thing I'm going to need to do is factor this denominator right here. So we'll move that over. So I've got x squared minus 5x minus 6. So that would factor into two numbers that make -6 and add up to make -5. X minus 6 and x plus 1. And then we get to divide them. Since I multiplied by 2 in the beginning, we got to divide by 2. So coming over here, then my final factors are going to be x minus 3, because I can divide 6 by 2. And I can't divide 1 by 2 evenly, so I move the 2 in front. So it becomes 2x plus 1. And in the numerator, I've got my 3x, x minus 3. Okay, so these cancel. So there is my factored version, which will help us a little bit. The first thing says the graph has a removable discontinuity, or a hole, at x equals 3, which is true, with a vertical asymptote at x equals -1/2, -1/2. That seems pretty accurate, actually. Let's check the other ones real quick. Has a vertical asymptote at x equals 3? Absolutely not. That was a removable discontinuity. The graph has a removable discontinuity at x equals 3 and -1/2. Nope, the -1/2 is definitely a vertical asymptote. Has a vertical asymptote at x equals 3? Nope, that's a removable discontinuity, so it has to be A. And that will bring us to the end of part 3. Let me know if you have any questions. Thanks so much. Bye, everyone.